in-memory column-oriented columnar database here. It's a in-memory, so column-oriented and columnar database here. All the databases earlier we have, it's a database. It's a database here, in-memory database. So other databases will store the data in the disk format level. Storage level, it will store the data. Storage level, so those will store the data. Storage level means, so if I talk about the example, so this is the CPU and memory and disk, right? So here, what will happen here? Suppose like, so if one user is doing the some query, is required the some data. So then all the data, all the applications data will sit into the, all the application data will sit into the where? Database level. Then first it will go to the CPU, then it will go to the memory, RAM memory here. Then it will go to the disk storage level here, disk, right? Storage. So then, so suppose like if you require something here, first request to go to the CPU. Then CPU will send the request to the memory, then memory to disk. Then disk level, you have the data is available. So the application will search where is your data, where is your query and all those things here. Then immediately once the application got it here, right? Application got the data, then immediately it will get the response back to the memory, memory to CPU, then CPU back to the user display, user front end, it will display the query results, right? Suppose like I need the last 3 months finance data or last 3 years finance data. Then so when you query from application level, that application will go to the CPU, the request will go to the memory, then disk level it will search the all the data, then that will be displayed to the users. So yeah, so this disk based concept is like a, so all databases will use the disk based concept. Databases like we have the in the market, so SQL Server, Oracle, right? And also DB2 and MaxDB. So then we have the ASC. So we have the databases in the market. All will have the disk-based concept. Will store the data in the file system level, either C drive or D drive. It will store the your application data here. So but there is a delay. Why? Because due to the disk, why we get storing the disk, so there is a NAS issues and IO issues and everything. So when it comes to the disk level, it will slowly, it will search it out, it will take time, it will give the response back to the users. So to avoid this kind of things here, SAP invented the HANA database here. SAP invented the one in-memory database. SAP invented here. SAP invented means they have released the HANA database in the market here, right? So what is the futures of the HANA database means? In the initial release of the HANA database is 2010. In the 2010, they have released the HANA initial release of the HANA database here, right? So why they have made it as a naming convention? HANA means, in the naming itself, what is mean by HANA database means it's a high performance, high performance analytical appliance, high performance analytical appliance here. So in the H, then so ANA HANA, okay? So ANA HANA, so called as the HANA database, high performance analytical database here, right? Analytical appliance here, right? So here it is not only storing the database, we can also do the some web applications also we can develop using the HANA database. That's why it's a appliance here, right? So then, so the concept SAP introduced it here. So we have the CPU based CPU concept here. Then in memory, in the in memory itself, your storage, your disk will be there in the in memory itself. In memory itself, you have the disk. So your request will go to the CPU, CPU to CPU, same common. Then main memory, memory. Then in the memory itself, your data is saving here. Your storage, your data is getting stored in the memory itself here. So what it will happen whenever any query, then it will go to the CPU, then CPU to memory. In the main memory itself, you have the data. Main memory itself, you have the data. Then immediately, so the searching the data, pulling the data from the main memory is compare 1 lakh times faster than disk. So request will go to the CPU, then it will pull it out immediately. It will give the response back. So the user is getting the fastest response when he is using the HANA database. He is getting very late. Why? Because request has to travel from the memory to disk, then it will take some time. Then again, disk to main memory. So this travel time we are minimizing, right? This travel time we are minimizing, and also the search functionalities we are enabling in the main memory itself here. So that's why SAP made a statement like it's a 1 lakh time faster than disk. Why? Because data storing into the main memory. If you have a lot of memory in your mobile, about like in mobile phones, so we have the so 8 GB, 16 GB memory phones are available. It will be very fast initially. Then you keep on loading all the applications and everything, and when the memory comes to the near to zero, then your mobile will start hanging, slowness, and all those things stuck something because because of the so memory is less. All the open applications are there the memory is very less, system will hang. But when you restart it, it will be very fast. Why? Because when you restart it, it will be the all the memory will be flushed out. So then why? So here the thing is what is happening. If you have the main memory, system will be fast. If you don't have that, in that self, data is saving into main memory itself. So your data is very speed. That's the concept. That's the logic they have implemented for the HANA database. That's why HANA is a in memory, one of the first in memory, and also one of the fastest database here. And one more thing is here, if you talk about the HANA database, HANA will store that. So normal other databases in the database level, there is a table. In the table, we have the rows and rows and columns. So data will be stored in the rows and column. Table means rows and columns, right? But when it comes to the HANA database, it has only columns, only columns only. There is no rows. Means row wise data will not be saved. Only columns wise data will be saved. So when the data in the columnar way, the speed of the database fetching the data is very fast. Row level data, business data storing the row level, it will be quite difficult to get the result. But here the column level, it will be very fast to get the data. So this is the so futures in the HANA database. That's why HANA we will call it as the one of the, it's a column oriented in-memory database. This is the one of the in-memory, the fastest database SAP released in the year of 2010. In the 2010, SAP released into the market here, right? It's a then what other features here? It's a type of the multimodal database, and also it's a commercial software, proprietary commercial software here. It's not like free to use it here. Like we will get in the Google open source software. It's a proprietary commercial software. Same all SAP softwares are the commercial software, which means you require the S user ID, client S user ID. So then you will get the access to this one. You can use it here. These are the main important thing here. So it's a in-memory column-oriented relational database management system developed and marketed by SAP SC. The what is the primary function of this HANA database is to store the data, retrieve the data as requested by the application. It will store the data which is coming from the application. It will retrieve the data as requested by the applications. Any applications, it will request the data here. Storing, retrieve, right? Storing and retrieve the data here. That is the main important thing here. In addition to that, it will perform the advanced analytics, text-based analytics, text search based, streamlining analytics, graphical analytics, then predictive analytics. There is a statistical data processing. There are the analytics capabilities, right? And it will include the ETL capabilities as well as in the application server, extract, transform, load the data. We can also extract the data from the other databases we can transform the data with understandable format by HANA database, and we can also load the data, HANA data, into the other databases also. That's we will call it as the ETL tools. ETL functionality is also available here, right? So that is the main features in the HANA database here. 2010 initial release, SAP released the initially here this HANA database, right? It's a high performance in modern HANA database developed by SAP. It's designed to handle the transactional data and analytical data. In both one database, you have the transactional and analytical. So normally we will call it as the one database, you have the OLTP and OLAP, online transactional processing, online analytical processing. But here other databases, either you have to use database, install a database, you install it, either you have to use that database, either transactional data or analytical data. If you need the analytical data, again, you need a separate database is required. But here in one database, you can use that database as a TP and AP. In memory technology, HANA stores and process the data primarily in memory, right? Significantly accelerating the data from retrieval purpose, analysis purpose. So compared to the traditional disk-based databases here, these all are the disk-based databases, but this is the in memory-based database here. It's a column-oriented storage. So data stored in the columns, which is efficient for analytical queries as well as faster access to the data points, better compression and everything. So why we storing the data in the columnar way? So that's why. So it will be very fast here. It's a multi-modal database. HANA supports various models, right? So including relational. Okay. So including relational database, graphical, spectacle, there are the stores, there are the different model database, it will support it here, right? So real-time capabilities. On the fly, we can make the business decisions. Why SAP made like on the fly, we can make the business decision. Within fraction of milliseconds, you will get the history of the table, sales table, history of the, maybe suppose like example, this is the sales table. You are going to release the one product, but you want to see the history of the how is the previous trend and everything. In that case, within fraction of milliseconds, you will get the results from the database level here. That is the main thing here, right? That is the main important thing here. Scalability, advanced real-time capabilities, and everything here. That is one of the important things for the HANA database here. It's a in-memory, the centric database management that runs on only Linux platform. This database runs only on the Linux platform only. So not the Windows and other things. HANA can run only on the Linux platform, and so it builds on C++ language. So HANA also there is a coding, right? They have to write the coding, developers, right? Which coding? C++ language, the screens and all C++ language and everything here. It's built on the Linux operating system only, right? That is the main important thing here. This can be used for multi-purpose, OLAP, OLTP here. In a single database, so multiple things we can use it here. So, and also data will be compressed here. Any data which is coming the 2 GB data, so there is a 10x compression will be used here. So almost 30 to 40% data will be compressed here. 30 to 40% data will be compressed here. Why? Because there the compression techniques are available in the HANA database. So this compression technique, so normally if any zip file, if any folder, if you have the one folder, if you right click and if you zip it out, this will be reduced. The data will be reduced, the size will be reduced, right? If it is the folder, the size will be huge size, right? Very high size data here. That's the reason here. So we can reduce the size. The size will be reduced by using the compression technique in the HANA database. There are some compression techniques are available here. Dictionary coding, run length. It will come when we are going to discuss. So inbuilt, it will use it here. When the when the database, it will use all the RAM to store the data and everything here, right? So here, so in the HANA database, here, it's a in-memory database here, right? High performance analytical database, in-memory database. It's developed by the SAP only, right? Unlike the traditional databases like We have the SQL, Oracle, DB2. This we will call it as the traditional databases, which store the data on the disk, but this will read the data into the main memory. That is the main extremely very faster processing and everything here, right? So that is the, so we can deploy the HANA in on premises, means your own on premises multiple ways, on premises, and also you can deploy in the on cloud, and also we can deploy in the hybrid also. Hybrid means a mix of the on-prem and cloud. Cloud means Azure, GCP, BTP, all that is called the cloud, right? So on-premises means your own premises, you can install it here, right? It's a real-time analytics, sales trend, financial reporting. We can do it here, live reporting. Then applications also will run on the this database, HANA database here. Predictive analysis here, customer risk modeling, customer, so predictive analysis and data warehousing capabilities, and many advantages we have here, right? So they are using the compression, reduce the need of the compress, means the data will be compressed mainly. When the data is coming to the HANA database level, data is compressed here, right? So why? Because in the other databases, the reports will take hours, but here the reports will take fraction of milliseconds, and in the real time, it will be the real time, right? When the transactions are happening, you can get the real time reports also here. Real time, the reports also we can get it out in the HANA database level here. That is the main important thing here, right? So in a HANA, so they have the inside inbuilt of the HANA, they have the some compression techniques. They have the data processing engines are available. Those will process the engines and everything to store the data inside of the here, right? That's why HANA innovated in the field for hardware and software. It's a one of the innovative database actually. That's why nowadays, if you see, all the customers are using the HANA database because, so because here the database is very fast, fastest database in the market here, right? Hardware and softwares and everything here. Compression mechanism, partitioning, aggregation, no aggregations here, right? So that is the main. It's a multi-core architecture. Only thing is you require the more RAM is required. Due to the changes in the hardware cost, you can also get the less cheap RAM memory, RAMs. You will get it out that you can use it here. Okay. So that is the main important thing about the HANA databases here. Okay. So similar functionality they have included in the tracks, but that does not get succeed. So then they have introduced the HANA databases here. The tracks also is like a, so SAP search engine, like it's kind of a search engine based concept. So similar features they have introduced in the, so in the HANA database. The text functionalities also they have introduced in the HANA database is also here, right? That is the main thing of the HANA database here, right? When it comes to the, sir, you said like we need to carefully plan the hardware requirement and software requirements here, right? Because HANA required the more RAM memory is required. So based upon the RAM, you require the CPUs. Then storage also you required. So what are the hardware requirements for the HANA database? And what are the software requirements for the HANA database? Software means DB, right? DB software we can download. Database client, right? Client software we will download it. But what about the hardware requirement for HANA database? So it's normal database directly fine, but it's a HANA, it's a in memory. All the petabytes of data, terabytes of data, GBs of data, tons of data will be storing into the in memory. Then how carefully we can plan the database size and everything, right? To achieve that kind of speed, so we also from our side we should have the enough memory capabilities and everything we have to arrange to the HANA database, right? So then let's talk about the HANA hardware requirements and software requirements here. Okay. So hardware. So first of all, operating systems, right? So what type of operating system you required for the HANA database here? HANA operating systems here. What type of operating systems, right? So operating systems means HANA can be installed only on the Linux platform, either SUSE Linux or Red Hat Linux. SUSE or Red Hat Linux. We can only install on the SUSE Linux or Red Hat Linux only here. right? So HANA runs only on the certified hardware vendors, like, so we can only install on the certified hardware vendors, right? It's not like that your favorite hardware vendor. It's a certified hardware vendors here. Like, so we have the hardware vendors like Lenovo, Dell, Inspiron, Fujitsu, right? We have the Cisco, HP. So they are certified hardware vendors. We need to procure the hardware from them only here, right? The hardware sizing depending upon the workloads, depending upon the load on the systems, right? SAP provides SAP provides same fix sizer tool and HANA hardware directory for exact sizing here. Exact sizing here. If you go to the HANA, there is a hardware certified hardware directory here. Maybe if you go to the SAP HANA, so here if you see the so HANA certified hardware vendors here, right? If you go to clear the all the, so you can see here vendors. These all are the vendors here, right? Cisco, Alibaba, EMC, Google, so Fujitsu, Data Store, Dell, Inspiron, Atos, Lenovo. These all are the certified hardware vendors here, right? So memory size up to 32 TB, up to 32 TB terabytes of data. RAMs also we can arrange it here. Means who will support 32 TB terabytes of RAM? Who will arrange it, sir? There are the many companies, many hardware vendors. They will terabytes of data. They will arrange it. So if we talk about that 12, 10 GB to 10 TB to 32 TB, like who will provide this one? See here. So IBM, HP, they will provide it. Then IBM Cloud, GCP, and Azure and Lenovo. Only these customers they will provide the these vendors, they will certified hardware vendors, they will provide the hardware to you, this much of hardware, this much of hardware, so they will provide to you. So let's see who will provide that 32 TB. So this kind of things here, right? So certified hardware vendors here you can deploy in the, so certified, and who are the hardware vendors you required, what is the CPU architecture, all the CPUs, the recommended CPUs are Intel Haswell CPUs are later are the recommended Intel Haswell CPUs, the Intel based CPUs, and the CPU names Intel based CPUs and certified hardware vendor, and operating system is either SUSE Linux or Red Hat Linux is required for the HANA database here. Right? Hardware vendor is required for HANA databases here. Right? You can see that depends upon this one. You will get the lot of things here. Right? So they will provide the 32. So what is the, maybe if you go more, little more. So then what is the model? What is the model for this one? Gen 10 HP. So how much RAM? So they are providing the, so 23, 3 TB, 3 TB, 4 TB, 6 TB, and 1.5 TB. So you can see based upon the CPU, based upon the appliance name, you can see the what they will provide it. All the information it will be there, right? That is the main important thing here. So memory. If you see, let me check who will provide 32 GB, 32 TB, not the GB. Only 6. Maybe gets 32 TB terabytes of RAM means it's not. So only Atos is providing. Remaining all other cloud providers and HP is providing. Atos and HP is providing. So only 32 TB. 32 TB. So Intel, this is the top end CPUs, top end, right? So this is the one. This is applicable for the BW, S4HANA, business systems, and all those things. You can see the model. System is based upon the Evident Extreme node controlled by the technology. Okay, OLTP node supported. Certified for the Red Hat Linux, SAP solutions, and everything here. Right? 32 TB means it's not like simple. terabytes of data. So one slot they are providing 32 TB, one slot they are providing. Great. So we can find out the hardware, certified hardware directories from here. So who will provide? So SAP recommending to procure the hardware from the certified hardware vendors only. Because those HANA will work that much of speed. That's why certified hardware vendors are required here, right? So hardware sizing depending upon the workload, how much you require depending on workload. So using the quick sizer tool, we can calculate the sizing and everything here, right? The CPUs, Intel Xenon CPUs are later are the recommended here, right? It supports the Intel with the X and virtualization will support virtual systems also. We can at least 8 CPU cores are required. At least minimum cores are required here. Right? So HANA memory. So normally, if you talk about the CPUs means CPU depending upon the RAM memory, you will get the CPU count also here. The memory count we can take it out based upon the quick sizer tool or the minimum. Either we can go with the T-shirt sizing method. The minimum for HANA database here. So 128 GB RAM memory is required for HANA DB. For the small companies, we can go for the minimum. If you go to the 256 GB, that is for the medium size companies. Then if you go to the 512 GB, that is for the large companies. If you go for the 1 TB, that is for the extra large companies here, right? Extra large companies here. This is we will call it as the T-shirt sizing methods. Small, medium, large, extra large. So minimum they required. Minimum they required. Sir, minimum only I will take the 1 TB means that is your wish. If you have the more you have the money, then you can take the much RAM also. That's not a problem. If you have the more RAM, then speed will be more, right? That is your wish. But minimum SAP recommending to have 128 GB RAM for the applications. But for the training, this is SAP recommendation. But training purpose, practice purpose, 64 GB RAM also fine. For sandbox, some development, for production, definitely it should be 128 GB. It's a more it's required here. It's a more you require this one here. That is the main thing of the RAM requirement. Depends upon the RAM, you will get the CPU requirement also here, CPU cores. But because one physical CPU will handle the 14 to 16 GB of RAM memory here, right? Example. So then if you take the two CPUs, then 28 GB, then 3 CPUs, then what is that? 32. So like that, if you go with the 128 GB, then 128 by 40. How many CPUs you required? So 9, 7. So this much of thing are required here. So right. So 128 by 14. Let me calculate it. 9, right? 9 CPUs. 9 CPU cores are required here. 9 CPU cores are required here, right? Which means each CPU will handle that. So based upon the RAM size by 14 means one CPU will handle the 14 GB of RAM memory here, right? So sometimes when you go to the cloud, in the cloud the variations are different here. In the cloud the variations are different. One CPU that we will call it as the vCPU will handle the 7 GB only. Then in this case, 18 CPUs are required for the 128 GB. Right? In the cloud, in either AWS or Azure, so slightly it will change here. Right? If you know one CPU will handle how much of RAM, then you have the 128 GB RAM or 1 terabyte RAM, then how many CPU cores are required. Normally in the cloud, there is automatically that they will define it. If you select the memory, automatically CPUs also will be selected. You no need to manually calculate it here. CPU into memory ratio, 1:14 ratio, automatically it will be selected in the cloud side. So only on-premises side, we need to calculate the carefully here. Why? Because when you are working on the Azure or AWS or everywhere, so this hardware requirement family will be chosen automatically here. Okay, so that is the main important thing. If you choose the RAM, that will come here, right? The OS, either SUSE Linux or Red Hat Linux is fine. SUSE means versions. I will explain about the versions also here, right? That is the CPU and the RAM requirement here. Okay. Then storage. Storage also it's required for the HANA database, right? So storage also it's required. The storage is depending upon the your RAM, your main memory here. Here we have the list of file systems called the root, USR, SAP. It's a Linux, right? Then we will call it as the file systems here. If it is a Windows, we will call it as the drive, C drive, D drive. So F drive, how we will call it as here also we will call it as the drives here. So slash and data, slash and log, slash and shared. Then so root USR SAP swap, then slash var, so slash temp, right? So slash log. So these and all the so OS, these all are the OS specific file systems. But HANA, you require these file systems should be separate mount points are required. Separate mount points are required for these file systems for HANA databases. So storage, we require the 10 GB. For storage, we require the 10 GB. For root, we require the 10 GB. USR SAP 50 GB. Then slash and data. So 3 into RAM size. How much RAM? That is the 3 times of data size is required. Log is, so it's a 1 by 2 of RAM size. 1 by 2 of the RAM size, or the max 512 GB is required. Slash and shade 1 into RAM size. This is the calculations. So swap 10 GB, var 10 GB, root 10 GB, and temp 10 GB, 10 GB, 10 GB is fine. But so this is the main for the HANA database. This is the main important thing for the HANA databases here. Okay, that is the main important thing for the HANA databases. HANA is a in-memory so database here, right? Root 10 GB, USRSCP 50 GB, 3 into RAM size, 1 by 2 of the RAM size here, 1 into RAM size, right? Suppose RAM size, suppose like your RAM size is the 1 terabyte, 1 TB you got it, right? Your customer take the 1 TB for RAM. Then based upon the 1 TB, how many CPUs are required here? 1024 into by 14. Then how many CPUs you require? So 1024 divided by 14. Then so 73 CPUs are required. We require the 73 CPU cores are required here. Then so memory, you got the memory. Memory we will get based upon the fixed size or memory, we will get the T-set sizing method. Memory will get based upon the data size. We will get the memory anyhow. But based upon the memory, we will get the storage. So CPUs, then storage. How much storage space is required? So then you can calculate it here. So root 10 GB plus then 50 GB USR SAP, then 3 into RAM size means 3 TB. So data folder plus so half by 2. So we can take the 512 GB for this one, then 1 into RAM size 1 TB for this one, plus so remaining and all the 10, 10, 10, 30, 40, so 50 GB. Let's take the 50 GB this one. Then we calculated how much, then this much of RAM you require, this much of storage you required here, space. So which means so 4.512 and 4.562, 4.6162. So which means 4 point around approximately 4.6 4.6 TB the storage you required. 4.6 TB storage. This is the calculations we required for HANA database. This 4.66 TB cake, you are splitting into the multiple partitions, 10, 50, 3 into RAM size, like that you are splitting. This is the, so the HANA structure, OS level, the file system structure should be how it will be here. So same as like how we have the D drive, E drive, F drive, how here. Similarly, we need to split the storage structure like this. We need to structure it here. The total 4.6 that you need to split into like 10 GB root, 50 GB USR SAP 3 into. So it's not my calculation, it's a SAP, the hardware requirement. hardware requirement calculations here. Okay, that is the main important thing here, right? So the network 1 gigabyte per second is minimum. So then 10 GB also it's fine. 10 Gbps, 20 Gbps is also fine, right? So the hardware, these are all the hardware requirement here, right? The small systems here, 64. So suppose like small companies, small systems here. So depends upon the RAM only. We have to calculate everything here. The RAM means how much we have to take it out here. The small, which means so 64 GB also fine, but 128 GB also fine. That is depends upon the customer budget and everything here, right? So that is the main important thing here. Medium company, large companies. So that is the here, right? So that is the OS. OS means SUSE Linux or Red Hat Linux. Then file system types, XFS file systems or ext4 file systems. That is the here. So RAM is the king here. RAM is the king here. Size is based upon the data set here, right? So RAM is the king here, mainly king. So because all the data stores into the RAM memory. So I memory we have to purchase it out here. But so if you purchase, if you follow the SAP recommendations, you can achieve the that much of speed of the HANA. Immediately will get the faster results. So that is the main important thing. Okay. This is about the hardware requirements or Linux OS versions, right? So OS versions like operating system. So we have the SUSE Linux. If we take it out, SUSE Linux 15 SP07 is the latest version. Earlier 06. Now I think recently they have released the 07 also, 05, 04, 03, 02, 01. So these are the current, which is in the valid status here. The latest is the HANA SLES, SUSE Linux Enterprise Server 15 SP07 is the latest in the market, right? So still customers are in the 06 only, right? So when you go to the HANA database here, HANA, what is the latest version means here? HANA 2.0 SPS 08 is the latest. Before that, we have the 7, 6, 5, 4, 3, 2, 1. 3, 2, 1. This is the HANA versions here, right? This is the latest in the market. And up to next 1 year, this will be the same. This will change yearly once they will change the version, right? This is the latest version in the market. Sir, why we have to call it as the HANA 1.0, 2.0 like this, right? Earlier we have the 1.0, Robo 1.0, Robo 2.0. So then similarly we have the Robo 1. HANA 1.1, HANA 2.0. What is the difference? They are the structure wise, the architecture wise, there is some changes are happened in the HANA 2.0, right? So I will explain it. Okay. So today, just what is HANA, why it is very important, what are the features we have, then what are the hardware requirements, how to calculate the hardware requirements for HANA database. Normally, you will not be involved procuring the hardware, you will not be involved in the sizing, the OS installation, all those things here. So your infrastructure team, they will be ready. They will, as per your requirement, they set all the infra, everything is ready. They will send to you. Then you can start doing the HANA installations and everything. That is the very important. Okay. So that's it introduction. Tomorrow we'll start discussing about the more about the what is the difference between the HANA 1.0 and HANA 2.0. So what are the architecture? How is the architecture? So that will take, that is also theoretical class only. So that we'll see. Okay.
Okay, there is one question, if you
Yes.
don't mind. Can we downgrade from 8 to 7?
Not
No, I
possible.
think
Only
not possible.
upgrade, only downgrade is not possible. Oh, so what we can do when you are upgrading the 7 to 8, you need to take the OS level snapshot backup. You have to take it out. Entire VM backup, you have to take it out. Then after
Okay.
upgrading, you face some issues or some challenges. You want to go back, then you can revert the snapshot backup. You can revert it. So that options
Mhm.
are available. You can revert it. By software itself, we don't have the option that we have to take the snapshot backup, the live VM backup, operating system backups. We have to take it out. That backups we can restore it.
Or we can take database backup and then restore that into
No, the
the.
software side we don't have the option, DB side and SAP
Okay.
side. So
Okay.
only
Got it.
the OS level tools. OS you need to, so OS those things we have to do that one. The database backup means that is only will take the DB backup, not the softwares and
Yeah,
binaries backup.
good.
So if you take the operating system backup and HANA binaries, HANA tools also will come. So that will be backed up. That will revert the size. That will revert the version. But DB backup will not revert the HANA version. Why? Because
Thank
you are
you.
only taking the data, not the software, right? So that's the main thing. So in that case, then we will call it as the snapshot backup or VM backup or OS backup. Multiple ways we can take it out. That backups we can restore. Okay, so that's it, everybody. Thank you. And
When your HANA migration class start?
we'll start it
Batch.
that HANA migration. Yeah, I am also